Why does a titration curve, when you mix a strong acid and a strong base, look the way it does? I'm going to show you why, while we do a little experiment without actually doing an experiment. I'm going to pretend that I'm mixing 0.1 molar sodium hydroxide with 20 milliliters of 0.1 molar HCl. Notice this is a strong base and this is a strong acid. I'm going to increase the amount of NaOH that I add. I'm going to figure out what my concentration of H plus and OH minus are, and figure out what the pH is at every step of the way. So, before I add any NaOH, the concentration of H plus is 0.1, because that's the concentration of my HCl, and it's a strong acid. Because my H plus is so large, I don't have any OH minus in solution, or very, very, very little. It's not going to affect anything. If you take the negative log of this concentration on your calculator, you'll find the pH turns out to be 1. So, what happens when I add 5 milliliters of the NaOH? Well, I've titrated away 1/4 of my acid, which means the concentration of acid that I have is approximately it's approximately 3/4 of what it was. Now, I'm not accounting for the fact that the volume is actually diluted here. I'm just going to assume that the NaOH itself titrated away 1/4 of the acid because we added 5 milliliters to 20 milliliters. See where the 1/4 comes in there? Because my H plus concentration is so high, I still don't have OH minus, and the pH of my solution is negative log 0.075. My pH is 1.12. That makes sense. My pH rose when I added some base. What happens if I add double that amount of base? I'm titrating away half of my acid. Well, let's say I have half of the H plus left over. There's still no OH minus because my H plus is still really high. My pH is negative log 0.05. My pH has gone up to 1.3. Ooh, rising. If I add 15, I've titrated away 3/4 of my acid. Still no OH, but my pH has risen to negative log of 0.025, 1.6. You can see the pH, every 5 milliliters that I add, it increased the pH by 0.12, 0.18, 0.3. It's rising faster as we go along. Once we've added 19 milliliters, I've titrated away 95% of my base. I only have 5% of my acid remaining, 0.005. Still pretty high, and I don't really have any OH left. But my pH has gone up to negative log 0.005, which is up to 2.3 now. Oh boy. It increased by 0.7 pH units, and I only added 4 milliliters. I want to do a little experiment here. What happens when I add 21 milliliters of acid? No, sorry, 21 milliliters of base is what I'm adding. Well, all of a sudden, all my acid is gone. I only had 20 milliliters of the acid, and now I'm adding 21 of base. You know what that means? I have an extra milliliter of base left over after I've titrated away all the acid. All of a sudden, I have excess base left over. What that means is that my pH is now negative log 0.005. Well, that's my pOH. my pH is now 11.7. Because my OH concentration is now what's dominating, and it's a strongly basic solution. Notice that at the equivalence point, when I added exactly 20 of base, when I started with 20 of acid, I went from an acidic solution with a pH of 2.3 to a basic solution with a pH of 11.7. If I add even more base, I certainly won't have any acid left, and I'll have 5 milliliters of base left over relative to what I started with. Long story short, my concentration of OH minus will be this, and my pH will be 14 plus the log of 0.025. My pH will be 12.4. Oh, that's so big. These are the pHs as I titrate a strong acid with a strong base. Let me just plot these for you on a graph. When I added 0 milliliters, my pH was 1. When I added 5 milliliters, my pH was 1.12. When I added 10 milliliters, my pH was 1.13. Sorry, 1.3. When I added 19 milliliters, my pH was 2.3. When I added 21 milliliters, my pH jumped up to 11.7. When I added 25 milliliters, my pH was 12.4. So here's my curve. It went up, and then shot up, and then flattened out. Oh boy, does this look like a titration curve. The equivalence point of this titration curve is right here at a pH of 7. Because when my acid and base have perfectly neutralized each other, I'm left only with water, which has a pH of 7, and sodium chloride, which does not affect the pH because Na plus is the conjugate of a strong base and Cl minus is the conjugate of a strong acid. These do not affect the pH of a solution. The pH is exactly 7 when you titrate a strong acid with a strong base. And the curve looks like this because you titrate your acid away, and then as soon as you reach equivalence, bam, you go from acidic to basic, like that. Best of luck in your own calculations.